Computer Science, Ganpat University at Ganpat. And his area of interest is in sensor networks, algorithms, wireless networks, VNet, cloud computing, and more. So today is going to take a session related to critical infrastructure and big data. So now I would like to invite Dr. Nirbhay sir to please take the session, and I hope all the participants will get more knowledge about this session. Thank you, sir. Up to you, sir.
Thank you, Professor Dr. Jugal,
Yeah,
for
thank you.
introducing, right? And I am happy that Raksha Shakti University organizing this special FTP for the benefit of academic fraternity, right? And the chosen topic is very interesting. The critical infrastructure, intelligent critical infrastructure, rather, right? So this topic is very interesting and need of the hour. Okay, and whenever we are talking about the critical infrastructure, right? So it includes uh, starting the intelligent way a mechanism for the IoT, for the cyber security, for the wireless sensor networks. See, these are the basic things, okay? And based on that, the huge data is generated. And once the data is generated either from the IoT devices or wireless networks or any kind of the systems or applications which is having the nodes, they generate the data and send it to the sync node, and then thereafter the sync node they process it, and thereafter they send to the cloud and storage. So data is the main, data is the next oil of the in fact for the next generation, we can say data is the one of the big assets nowadays. Okay, so and data is very precious. Unless and until we have the data in a specific required format, right? So otherwise there is no use of the data. Use data is generated, and if you are not applying the data mining technique and data aggregations, we are not removing the redundancy, right? Then there is no use. Okay, because if you are not applying the intelligent way the aggregation technique, okay, on the wireless sensor networks or IoT, then the huge data will be transmitted over the network, and due to that, the network will be jammed, the network will not work. Okay, so many things, delay will be there. Okay, power consumption, whenever we are talking about data aggregation technique in wireless sensor networks, all the nodes are basically they are embedded with the energy battery, right? So all the sensor nodes are based on the battery. Okay, so Jugal, I'm going to share my screen, and I have prepared few PPT, and basically we'll be talking about the data aggregation, and then if the time allow, we will go for the cyber physical system, these critical issues, and then we will see the data analytics through the Wireshark. Okay, so Wireshark is very popular tool which you can use for the a security analysis and a data, right? So I hope no one has covered the wireless sensor network critical infrastructure. Is it, participants?
Yes, sir. We can see the slide, but yeah, if you select the slide, we'll see it.
Right. So let
Yeah,
me,
we can see.
yeah, let me close this first. Okay, or issue this. Professor Jugal, I am asking that no one has covered the data analytics and data aggregation technique in the wireless sensor networks.
Yeah,
Critical
not yet,
insight,
sir. It's
right?
fine. Yeah,
Right.
no one has covered that, so you can take it.
Okay. So here, see, the topic which I have included here, which I have decided after talking to the coordinator, that the topic is data analytics and security in wireless sensor network, a critical infrastructure system. See, whenever we are, just a moment. See, whenever we are talking about the critical infrastructure system, uh, always it relate to the networks, it relate to the the cyber physical system, which includes the networks, IoT, right? And these things are there. Okay, so data analytics and security issues, these are the two things that I will be talking here as part of today's session. So okay, so you can see here, I hope my screen is visible, everyone, right? Professor Jugal, can you see the screen? One
Yes, yes, sir.
participant. Okay. Thank you. Right. So I am Dr. Nirbhay Chaubey. I completed my PhD from the Gujarat University, Ahmedabad, and currently I am the Associate Professor and Dean of the Computer Science, Ganpat University. Right. So my talk will be focused on the data analytics and security in wireless sensor networks with respect to the critical infrastructure system. Right. And if time allow, we will cover the next topic related to the data validation and using the wires are right. So this paper basically, this we have referred to more than 25 papers to prepare these slides. Okay, so data analytics and security issues, right? So these are the disclaimers, because whole things that we have covered in this presentation, in this topic, right? Topic of the talk, I have listed as part of the reference. Okay, so you can see at the last all the references which I have referred to prepare these slides for the presentation, right? Major objective, see, of this talk is related to the data, how the data is generated, right? So from the wireless sensor networks, what is the use of the data, how the data mining is done, what are the tools and technique, and I suppose many of the expert, they already have taught you about the these data analytics tools and technique, right? So the major objective of this is to cover the aware the wireless sensor networks, design issues and structure of the wireless sensor networks, and understanding the communication structure of the wireless sensor networks, analyzing the protocol stack and algorithms which are available, right? Thereafter, the security. Security is the major concern, okay, in the critical infrastructure. When and security is the part of the intelligent critical infrastructure, we can say. You are making the device intelligent, you are making the system intelligent, but security you cannot overlook. Okay, so security play a very important role in almost all the layers of the critical infrastructure system, whether it is the IoT or whether it is the cyber physical system or wireless sensor network. If you see the evolution, right? Evolution, if you see wireless sensor network to the IoT, and IoT to the the cyber physical system, and the cyber physical system consists everything, consists of all the networks, right? So what are the protocols and algorithms? Most of the protocols you can see which are wired, they will not apply for the wireless. Okay, and even if you have the wireless system like infrastructure based, those kind of algorithms and technique will not be applicable for the infrastructure less networks. So whenever we are talking about the wireless sensor networks, you can see there are two kinds of WSN also, wireless sensor network, infrastructure base and infrastructure less. And again, the algorithm technique is the data aggregation technique and the network layer technique algorithms are completely different, right? So the major objective of these, you'll be aware about the security requirements, security taxonomy, and how the data gathering is done, right? So data collection is the one part, and whenever you are collecting the data, right, you'll be collecting there is a high chance that you will be having the duplicated data over there, and there is no need to send the same data again and again to the destination. You need to avoid this. You need to send the filtered data to the destination. If you are sending the garbage data, the same data you have collected from the 100 nodes, 20 nodes, and you are sending the same data to the destination, then there is no use, right? So because it is the useless information, because it requires lots of computational processing, because it consumes the energy. You need, whenever we are talking about the critical infrastructure system, everything should work in optimized way, whether it is the processing power, whether it is the energy battery or aggregation technique, the algorithm that you have developed, the node which they apply the algorithm to process the data should be very optimized. Okay, otherwise network will be busy, critical infrastructure, the whole infrastructure will be busy just processing the unwanted data. So you should avoid this, right? Understand the aggregation technique. Aggregation data collection is the one part, and data aggregation technique is the another part, right? So these are the things that you will be able to learn from this lecture. And what are the tools? There are so many tools are available where you can which you can use for the wireless sensor networks, like NS3, Network Simulator 3, NS3, OpNet, OmNet, right, Glomosym. These are the very popular simulations tools available for the sensor networks, right? So these are the objective. These are the outlines that I have listed here: wireless sensor networks and its applications. So as part of the critical infrastructure, intelligent critical infrastructure, we'll be seeing that the sensor networks are there. And the sensor networks, the kind of applications, what kind of applications where the sensor networks can be applied, right? And what is the basically structure of the wireless sensor nodes? Like when you are having the nodes is having the structure like a memory. Because sensor nodes, they are having the computational processing unit, they are having the memory unit, they are having the energy unit, right? So many things are there inside the node, right? And most of the company which they prepare the kind of the wireless sensor nodes, right? They do regularly the research and development in this way to optimize the energy, right? Because energy is a very important concept in the wireless sensor network, because most of the wireless sensor nodes are having the battery enabled, right? So they are having the battery, they work on the battery for 2 years, 3 years, 6 months, right? Once the battery time lifetime is gone, right, the network will be down. If any node is down, the entire wireless sensor network will be down, right? So thereafter, the next topic which I have listed, we will be covering, that is the communication structure of the wireless sensor networks. How exactly the communication is done in the wireless sensor networks, right? And what are the security requirements in wireless sensor network? What are the taxonomy of that attacks? Okay, so definitions, security challenges in wireless sensor network, simulation tools. Okay, many tools are there. Some tools are paid, some tools are free, right? Where you can use the, the simulations tools you can use, and you can create the scenario environment of the wireless sensor networks, right? See, simulation tools is required when actually you want to see at the first stage how the exactly wireless sensor networks algorithms the work. Okay, because creating the wireless sensor networks in the real time itself is a huge investment. You need to purchase all the the devices, networking devices, routers, nodes, right? And it is huge investment. So rather than going to the straight way real time experiment, you can have the simulations tools, and through the simulations tools, you can create the networks. You can create the networks and you can generate the data. Or even if you have the generated data, okay, for example, wireless sensor body area, wireless sensor networks, where the person is having the so many sensors, health related sensors to monitor the body, right? And they generate the data, and the data is stored somewhere. So this is the one kind of healthcare application I'm talking. Second application, you can see the agriculture applications, right? So here you can see the kind of the data is generated. So if the data is, you are having the data, you can straight away you can use in the simulations tools, and you can analyze by applying algorithms, right? Data aggregation technique and research direction. We will be also talking about the research direction of the wireless sensor networks, and then we will conclude. So this is the overall, the outlines which I have prepared for the today presentation. Okay. So let us go in details now. Overview of the wireless sensor networks. And wireless sensor networks, it is a combination, right? It is a combination of the base station, that is the sync node that we are talking, and the number of wireless nodes, sensor nodes that you can deploy in the area, and that area is known as the sensor field. Okay, so you can see the wireless sensor network consists of the base station and the number of wireless nodes which are deployed in the field, in the area, which are known as the sensor field. Okay, and it is the group of specialized sensor. You please see, the sensor are various kinds. Okay, the transducers, sensors are various kinds. Like one example I am giving you, the monitoring the temperature. So there you need a different kind of the sensor nodes. Okay, monitoring the heartbeat, you need the different kind of sensor nodes, right? So sensor nodes, most of the company they develop the sensor nodes, okay, specialized for the specialized domain, like a healthcare unit, agriculture unit, right? In smart city, right? For the monitoring the soldiers, for monitoring the area, for monitoring the object, right? Many sensors are there, right? So you can see that with the communication infrastructure intend to monitor and record the condition and diverse locations, right? So location is very diverse. Okay, and it is deployment of the several devices equipped with the sensors. Okay, so that performs the collaborative measurement process. So wireless sensor networks, where the sensors you have deployed, okay, all the sensor nodes they work together, okay, and they work together in the cooperative manner. See, the sensor networks will be established. The network, see, always the networking means the communications, talking to each others, right? So these can be established in the multi-hop way. Multi-hop way means the hop by hop. So sensor nodes, basically they are having the radio signals. Okay, if you want to collect the data from the sensors, they are not work based on the wire. Maybe, I mean, there are wired based sensor networks also there, but I'm not aware, right? Most of the wireless sensor networks are there, right? So if you want to give some instructions to the sensors they sense the information through local, right? So like temperature, if you want to monitor, object movement you want to monitor, enemy movement you want to monitor, vehicle movement you want to monitor, right? Anything you want to monitor, you have to deploy the sensors, right? If you want to monitor the home, if you want to monitor the smoke, okay, eh, uh, right? So you need to deploy the sensors. You have to give the some information to the sensors, and sensors will collect the data, right, and send it back to the sync node, right? But everything happens in the collaborative manner and it works in the multi-hop. Whenever we are talking about the multi-hop, the node is having the capacity, right? So we are talking about the hop. Hop means the area, 20 meter, 30 meter, but the one node is having the radio, transmission channel capacity is 20 meters. And if you want to send the data to the 100 meters, how many hop you need? You need the 5 hop. 20 meters multiplied by 5 is equal to 100 hop. 100 meters, because you want to travel, you want to transmit the data from the source node to the sync node, right? Then it is the multi-hop, and these all things will work in the collaborative manners, because the network is established when the all nodes they help. If any of the nodes is not helping to establish the network, then the network is failed. Network will not be established. Even the root is not established, right? So this is the way that you can establish the wireless sensor networks. Yeah, this is the very the topic of this entire FDP is intelligent, critical infrastructure system. See, one thing, this is the data which is I have taken from the Google, okay, and you can see the Cisco auditors, and this is the 6 years old data, okay, 6 years old data which I am presenting here. Wireless sensor networks to the IoT to the big data. This is the evolution. Okay, and this is the part of the critical infrastructure. Now, here you can see the 90% of the world data has been created in the last 2 years. This is the 5-6 years old data. And you can see here the 1.1 billion data points generated by sensors daily. Whenever we are talking about the data analytics, we should first aware from where the data is coming. This data is applicable for what applications, right? This data is having what kind of features. People, they are normally download the data from Kaggle and somewhere, and they have start applying the data analytics. But right, but you should be aware the kind of the data which has been generated, whether it is from the agriculture sector, whether it is from the military sector, whether it is from the hospital medical data, right? So see, these 1.1 billion data points generated by sensors daily. Okay, this is the old information, 5 years. Okay, 500 gigabyte data generated by an offshore oil rig weekly. Now it may gone to 1500 gigabytes, and 10,000 gigabits data generated by a jet engine every 30 minutes. And these, I am sure that these might has also gone to the threefold, right? So 10,000, we can say the 30,000 gigabytes, right? 2.5 billion gigabit data generated worldwide daily. Okay, so just you think, that is the reason that I am calling that the data is the next oil, and this is the evolution in the critical infrastructure, right? So you can see the wireless sensor networks, okay, whether it is the power generation, power supply, power transmission, whether it is the military information, everywhere the intelligent infrastructure is required, whether it is the smart city, whether it is the healthcare system, whether it is the financial sector, right? Everywhere the intelligent critical infrastructure required, right? And whenever we are talking about this intelligent infrastructure, data play a very big role, okay, and you have to process the data very intelligent way, okay. But you must see from where this data is generated, whether this data is generated through the IoT devices, whether this data is generated through the these systems, or whether this data is generated through the some Bluetooth technology from the GPS. Like whenever we are talking about the intelligent infrastructure system, intelligent transport system, you can consider this is the great example of intelligent infrastructure system, intelligent transport system. right? Two of my PhD students, they are working in this area, intelligent transport system. One fellow is working for the BRTS Ahmedabad, another one is working in the area of yeah, the traffic and comfort purpose for the Surat BRTS, right? So they are working in these intelligent transport system. So intelligent transport system, if you make the people's travel comfort, if you see that the yeah, buses which are running empty, right? If you make the algorithm so intelligent that they can give the information early, right, related to the number of passengers who are coming to travel, right? So many ways are there where you can work in the intelligent critical infrastructure system. So many things that I will be talking about, right? But see, every these infrastructure, they generate the data, huge data they generate, and you need to process it, right? Now, many people, I am sure that the few of the experts, they must have discussed about the data, but right, so they discuss from here, right, big data analytics, right? They discuss about the tools, right? So learning big data analytics itself is a requires the huge time to learn, right? The tools and technique. But see, I'm putting this entire scenario to you people so that you have idea. Okay. See, this is the sensor field. All of you are able to see this. Are you with me? Yes or no? Can one participant tell me whether you are with me? Anyone? I'm connected.
Yes, sir.
Okay. Who is this?
Sanjay.
Okay. 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 Right. Okay. So, okay. So you can see here that so see this is Professor Sanjay. You can see here these are the components, right? This is the sensor field. Okay, this is the sensor field. These are the sensor nodes. You can see 1, 2, 3. Okay, all these things that generate the data. This is the raw data. See, this is the process, right? So raw data is generated by these nodes, and thereafter these nodes, they send it to this node. Okay. Okay, this may be the cluster. Okay, so there are various kind of the data aggregation, data analytics happens. Okay, so aggregation, you can see this is the one cluster, this is the another cluster, this is the another cluster, right? So three cluster are there, and all these are the part of the critical infrastructure system, right? And they generate the data, and these are the simple nodes. These node is known as the sync node or cluster head if it is the cluster. So this is the cluster head. Cluster head cannot be the down, please remember. The cluster head, the algorithm designed in such a way that whichever the node is having the high energy, automatically it will make the cluster. For example, if these three nodes are there in this cluster, and this node is having the 20% energy, this node is having the 80% energy, this node is having the 100% energy, then this node will become the cluster heads. And if this node is down, automatically 5%, 10% threshold, then this node will become the cluster node. So whichever the nodes is having the high efficiency, the high energy, then it is the cluster head. And the cluster head will transmit all these raw data generated to the sync node. And now the sync node will process these, apply the aggregation technique, and send it to the storage area. So this is the thing, main storage. So you see, this is the source node which we have talked. This is the sync node, right? These are the components part. And here you can see the main storage is there. So this is the main storage. Okay, so main storage, 1, 2, 3. Okay, 3 storage are there. Okay, so you can see the data is stored here, but data is not in the proper format. So data should be processed. Okay, so you can see for the process, the big data platform tools technique are there. So see the beauty. Okay, now the data is generated from the sensor nodes, aggregated is there. After this storage, the big data platform tools play the role. So Hadoop, MapReduce, HBase, these are the big data platforms tools are used. And thereafter, based on these, you need to process and you need to generate the reports. You generate the query, you apply the data mining technique. Then this is known as the analytics. Okay, so these are the platforms, these are the analytics. So there are two things here. One is the big data platforms, that is the tools and techniques where the data you can process it, and these you are having the big data analytics applications, you are having the reports. Okay, so data infrastructure feature, you can see the external multiple format, multiple locations, multiple applications. Thereafter the raw data is there, so raw data is here. Thereafter the transfer data, and then the big data analytics. So this is the part of the big data analytics in critical infrastructure system for the wireless sensor networks. Okay, so you can see the big data in wireless sensor networks, right? Then overview of the wireless sensor networks. Now this is the things, because we have talked about the data generated, and this is the one scenario which I have talked about, the big data analytics, right? Starting from the data gathering to the data analytics, right? So one scenario, one case study we have seen, right? Various, sensor networks are there, and sensor network, they are self-configured. If any node is down, they can configure it to monitor the physical or environmental conditions such as temperature, sound, vibration, pressures, and motion, right? So these self-configured wireless sensor networks nodes are there. Each wireless sensor node cooperatively pass their data through the network to the main location or the sink where the data can be observed and analyzed. Wireless sensor nodes, right, contains the hundreds of, see, whenever the sensor nodes are there in the critical infrastructure, for example, take the critical infrastructure of the power generation and power distribution in the country, right? You have to make it the very intelligent way. Otherwise, if any attacker will, the attack on your, because the whole things is on, the cyber physical system, right? The whole thing is available on the cloud data, right? The data is there, right? And control system is also basically connected through the SCADA system, right? So control system, if any attackers attack on the control system, the whole power generation and networks will be down, right? uh, and this has happened in many countries. This is the big threat, uh, right? So power systems down, right? So wireless sensor networks nodes contains a thousand of sensor nodes. So they maybe the small size wireless sensor nodes networks, maybe the medium size wireless sensor networks, or the big size wireless sensor networks are there, right? And communicate among themselves using the radio signals. So please see that the each of the nodes, they communicate through some signals. It may be the fiber, it may be the radio, it may be some other media of transmission, right? But most of the wireless sensor networks nodes, they transmit the data through the radio signals, right? So wireless sensor nodes enable new applications and require non-conventional paradigm for the protocol design due to the several constraints. Here you can see, owing to the requirement for the low device complexity together the low energy conservation, right? So if you are having the low energy consumptions, then the network lifetime will increase. Okay. For example, if you optimize the energy consumption, okay, of the wireless sensor networks, obviously the lifespan of the network will increase. Okay. And the proper balance between communication and signal data processing capabilities must be found. Okay. And this motivate the user effort in research activities, standardization process, industrial investment in this field for the last 2 decades, if you see, right? And you can see the many applications are there of the wireless sensor networks. So gain considerable popularity due to their flexibility in solving the problems in different application domains and have the potential to change our lives in many different ways. So wireless sensor networks have been successfully applied in various application domains, right? It may be the military application where the critical infrastructure is there, right? Wireless sensor networks, you make it the network so intelligent critical infrastructure, and military applications like integral part of the military command, military control, communications, right? And surveillance system, like you can monitor the enemy, okay, computing power, intelligence, battlefield. If a battle is going on, or you have planned some any military application, military any government military, they have planned for the battle, right? So battle surveillance, you can see, and there the data is also generated in military application. You can locate an enemy or a certain strategic feature and targeting system. So this is the kind of the military applications. Area monitoring, this is the another kind of the applications of the wireless sensor networks where the huge data is generated. Like area monitoring, the sensor nodes are deployed over the region where some phenomenon is to be monitored. When the sensor detect the event being monitored, like heat and pressure, like industry, critical infrastructure where is used for the industry, right? So where you can monitor the pressures, monitor the like boiler pressure, okay, where the heat temperature is almost 50 degree, 60 degree, 70 degree temperature is there, right? Boiler, maybe some high also. So the event is reported off to one of the base station, which then take appropriate action. So this is the kind of the area monitoring. So second application, the first applications of the wireless sensor networks, we have talked about the military application. Second, we have talked about the area monitoring. Third, transportation, which we already have discussed, like intelligent transport system. If you want to make the entire system in transport system intelligent, right? The, right there you can also use the wireless sensor network. So real-time traffic information is being collected, like you can deploy the sensor network, you can deploy the small nodes to the roadside RSU, roadside unit. It is known as the roadside unit, RSU. You can deploy these small sensors to the roadside, okay, and you can give instructions to the nodes. They will pass the collected information to the cluster nodes or to the sync node. A sync node, they processes these data, right, and make it some data analytics, right? So real time traffic information is you can collect it from the wireless sensor nodes, right? And so this you can consider as part of the intelligent transport system. And based on the analytics, based on the analytics of the data, you can give alert to the drivers. You can give alert about the congestions. If some prediction algorithms you have applied, you can give some instructions to the travelers, to the drivers, to the passengers, right, about the congestions, about the traffic problems. right? So this is the third application which I have talked about, the wireless sensor networks. Fourth is the health application. Okay, so here again the critical health application is very critical, like a healthcare hospital data is very critical, critical data and very sensitive data, right? Usually hospitals, they hesitate to provide the real data to the researchers, right, community for carrying out the research work. So health applications for the sensor networks are supporting interface for the disabled, integrated patient monitoring, diagnostic. You can diagnose the kind of the diseases, right? Drug administration in hospitals. So hospital data is very critical and it is a part of the cyber physical system, critical infrastructure system. These things you need to make it intelligent so that no one can attack no in the security part. Otherwise, if someone will intrude in your hospital management system, right, where the doctors have prescribed some medicine, right, and medicine to be given by to the patient by the nurses, and if some intruder come in the picture, right, they have access your data, right, and they change the medicine prescription given by the doctors, right, and they the whole thing will be a mismatch, because and the wrong medicine will be given to the patient, which is very critical things, right? So telemonitoring of the human physiological data, tracking and monitoring doctors, so remote surgery, remote monitoring. Okay, so remote help. Okay, so based on the some sensor networks, wireless sensor networks for the healthcare applications, you can have, right? So this is again the very critical infrastructure part. So we have talked about many applications. We have talked about the military applications. We have talked about the area monitoring. We have talked about the transportation. We have talked about the health, right? So fourth one, we have talked about the health. Fifth one is environmental sensing, right? So environmental sensor networks to cover many applications of the wireless sensor networks to earth science research. Okay, and this includes the sensing volcano. If you want to monitor the volcano, ocean, glacier, forest, right, and some wrong thing happening in the inside the ocean, right, inside the sea, you can deploy the small nodes, right, to monitor these kind of things. So you can monitor the water quality, you can monitor the air pollution, you can monitor the forest fire, right, in the forest, you can monitor the greenhouse monitoring, you can monitor the landslide detection in the hilly area, right? So these are the things that you can see, a wireless sensor network for critical infrastructure system where the environmental sensing is there. So sixth application which I have talked about, the environmental sensing. Now the IoT. Okay, IoT is not. Yeah, IoT is what? IoT is nothing but it is the combination of the sensors. It is combination of the sensor nodes. It is the combination of the communication system, devices. Right. So IoT is the paradigm. Okay, IoT is paradigm. If you see from the sensor networks to the critical infrastructure. And so so wireless sensor networks are recognized the key enablers for the IoT. Okay, because the sensors are there, communication system is there, then the IoT is there, right? So devices are there, Internet of the Things, the whole devices will be known as the one object, and the things, they will be connected to some communication channel, some internet, right? So internet media. So that is the reason that it is called the IoT. So wireless sensor networks are recognized the key enabler for the IoT paradigm since its inception. Okay, since the inception of the IoT, the wireless sensor networks. So you can see the wireless sensor network to the IoT, right? To the critical infrastructure system, to the cyber physical system. Whenever we are talking about the cyber physical system, it includes everything here. It includes the wireless sensor networks, it includes IoT because it is a part of the critical infrastructure, right? It includes the processing power. So many aspects of the life, such as connected homes, connected cities, connected cars, connected roads, these all are the objects, right? Car is the one object, right? So you can consider as a one thing. That is the reason that it is known as the Internet of the Things, right? So connected to the cities, connected to the cars, connected to the bus, connected to the roads, road to devices that track an individual behavior, right? So this is the fourth, this is the sixth kind, not fourth, sixth kind of the application which we talk about the IoT, right? The things where the communication system, right? So then seventh one is industrial monitoring. So wireless sensor networks have been developed for the machinery condition-based maintenance, CVM, right? Condition-based maintenance, as they offer the significant cost saving and enable new functionalities, right? So this is the seventh kind of application we have talked. Eighth applications of the wireless sensor networks, that is the structural monitoring. Okay, structural monitoring, you can see like the huge structure happening in the real estate, like flyover, like embankment, tunnels, bridges, engineering practices, right? Building infrastructure, right? Here, wireless sensor nodes, these networks can be utilized to monitor the movement. Okay, so movement within the building infrastructure. Okay, so these practices to monitor the assets remotely. You can monitor the things from the remote place, right? Without the need for costly site visit. You should not go there by just driving 2 hours, 3 hours, and in wasting the fuel. By sitting in your office, you can actually monitor these things if you have established the sensors networks, wireless sensor networks. So this is the eighth or ninth application which I talked. 10th applications, you can see the agriculture sector. So using the wireless networks frees the farmer, right? Using the wireless sensor networks, you can free the farmer from the maintenance of wiring in the difficult environment like irrigation. You can make the irrigation automation. You make the sensors, right? Deploy the sensors automatic when the water requirement is there. Automatic the motor will start and irrigation will be done, right? So irrigation automation enables more efficient water use and reduces waste, right? Next is so these applications, 10th or 11th we have talked social sensing based duty cycle management for monitoring, right? So this is the another applications which I am talking about, the social sensing based duty cycle management. So wireless sensor networks nodes are energy constrained scenario, event monitoring using wireless sensor nodes. Wireless sensor nodes suffer from the ineffective sensing for rare events, event monitoring or sensing event if there is a no event to monitor or sense. Example, submarine monitoring in underwater surveillance. Okay, so underwater, that is the UWSN, underwater sensor networks. This is the another area where the huge data, whether you can actually deploy the wireless underwater sensor networks and huge data, you can actually collect it from the sea and you can process it. So submarine, if you have some submarine monitoring, that is the undermine, right? So possible solution approach like duty cycle management. So these are the things, but again, these are having the limitations. Okay, so Advancement of wireless sensor networks like and alarm system for underground coal mines. See, in India or in Canada, you can see the huge coal mines are there, right? Canada is also like, if you see the Sudbury area, right? Huge coal mines are there. So you can monitor the fire, okay, in the coal mines, and you can give the alarm system. So fire, this is another case study which I am basically covering here, where the huge data is generated, right? So you can deploy the sensor networks, okay, and sensor networks will give the information, and accordingly you can process the data and give alert, and you can give alarm to the area or to the concerned people or all the stakeholders. So fire monitoring and alarm system for underground coal mines, board and pillar panel using the wireless sensor nodes. Wireless sensor nodes based simulations model for building the fire monitoring and alarm FMA system for board and pillar coal mine. So there are type of the coal mine like board, pillar coal mine, and the fire monitoring system has been designed specifically for board and pillar based mines. It is not only capable of providing real-time monitoring and alarm in case of the fire, but also capable of providing the exact fire location and spreading direction. See, so this is the things, right? You can find the exact fire location, but if exact location, latitude, longitude, it will give you exactly, right? So continuously gathering the information, analyzing the information, data, and storing the real time information. So temperature sensors are there. You can see this is the cooler pillar, okay, and this is the temperature things they monitor, and they, so these data, this is the thing, this is the sensor field mining area, okay, and they collect this information and pass it to the um, sync node or to the cloud, and process and do the analytics. So this is the fire monitoring and alarm system, right? So very good case study of this, where the data generated and analytics is done. Second is the wildlife detection using wireless sensor networks, right? So like you can monitor the animal, you can monitor the object in the forest, wildlife detection, and you can monitor the fire also, right? But here even the wildlife detection, you can see the wildlife detection using the sensor node. So this is the basic station, okay, this is the sensor nodes, all these sensor nodes, okay. So this is the another area where the wireless sensor nodes. Then comes the wireless body area networks. So another case study I can take here, that is the wireless body area networks, okay. So you can see the wireless body area networks at W-band have recently gained the very popularity due to their ability in providing the innovation. It is the cost-effective, user-friendly solution for continuous monitoring of vital physiological parameters of the patient. So you can see the doctor is here. Here is the patient, okay, and the patient is having, you know, the embedded or type mind sensors. Okay, so MG sensors, CG, blood sensors. Uh, this person is having the sensors, okay, uh, and uh, and they sense the data, send it to the system thereafter, okay, and real time database is there, and then doctor monitor this. So this is also happening and using this wireless sensor network. So wireless body area network, you can also consider W-band. Wireless body area network have recently gained popularity due to their ability in providing the innovation, cost effective, user friendly solution for the continuous monitoring of the vital physiological parameters of the patient. Monitoring chronic and serious disease such as cardiovascular disease and diabetes. So cardiovascular disease like heart attack or these things. If anything wrong happening in the heart, right? Sensors related to heartbeat, actually they monitor it and give it information to the doctor. Doctors, they accordingly give you the patient informations. They inform to the patient and take the treatment. So this is the area, this is the another area of the wireless applications, where wireless sensor networks application, where you can see for the health monitoring, right? So types of the WSN, wireless body area network, there are many kind of the body area networks and sensors are there. You can see the body area network presents the state-of-the-art technologies in the field of the wireless communication as well as remote health monitoring. In this technology, tiny sensors are implanted, right? So you can see this is the human, tiny, small sensors. For example, here ECG, BP, glucose, EV, right? Emotions, cardiovascular, glucose, PDA, personal device assistant, PDA phone, right? So all these, these kind of the sensors embedded, okay, here, okay, implanted here in the human, inside the human body, or embedded. You can bind it also in the hand and in forehead, right? Embedded in the external clothing, okay. So in the hand clothing or something, right? There you can actually embed it, these kind of sensors, and sensors will sense this information and pass it to the doctors, right? These sensors collect the important health parameters like blood pressure, they can collect the blood sugar, they can collect the heart rate and other vital parameters. So for implanted sensors, like see, pacemaker is there. This is the one sensor, pacemakers. So they actually monitor the surface sensors, electrocardiogram, ECG, and external sensor proximity sensors. Then implanted sensors, encephalogram, EEG, accelerometer. You can see electronic peel. Okay, so EMG, electromyography. So infrared sensor you need, alcoholic sensors, blood pressure, drug delivery pill. Okay, so these are the kind of the external sensors, and these are the implanted sensors you can see for this purpose. Like pH value or glucose if you want to monitor, right? So deep brain simulators is there, and external gas sensors is there, right? So these are the another applications of the wireless sensor networks, where the data is generated, huge data is generated from these nodes, right? Because you are monitoring the person's health, okay? You are monitoring the person's health, and this data is generated, okay? And you are making this data in useful manner. Then comes the agriculture intrusion detection using the WSN, wireless sensor network. So this is again the part of the intelligent critical infrastructure, where the agriculture intrusion detection is there, AID. So you can see here the cell phone, here is the farmer house, this is the case study, right? And here it is the GSM, here it is the sync node, and here it is the, this is the wireless sensor field. So wireless link is there, okay. These all are the small links. Here it is the intruder, okay. So they intrude in your system agriculture field, because this sensor field is the part of the agriculture field, right? And intruder is there. And this is the gateway. This one is known as the gateway, and this is the sensor node. These all are the sensor nodes. Okay. So this is the another example, another case study of the prototype for agriculture intrusion detection using the wireless sensor nodes are deployed over an agriculture field. Here you can see each of the board are enabled with two type of sensors, passive, infrared and ultrasonic, right? And when the intruder enters into the field through the boundary of the field, or PIR sensor detects the object. So the ultrasonic sensor sends the distances at which the object is located. So this is the ultrasonic sensor. They sense the distance, right, at which the object is located. So for this purpose, then a layering concept is there. So this layer 4, layer 3, layer 1, layer 2, layer 1. So layer 1, you can see the physical layer. Layer 2, you can see the, the data link layer. Layer 3, you can see the the wireless routing, and layer 4 is the SMS and alert you can send, right? So this is the physical layer, the sensing by passive infrared sensor. So they are using the infrared sensor. They sense the node, sense the data, and then sensing by ultrasonic sensors. These are the physical things, right? Processing it to the microcontroller and send it to the network layer, and then network layer. These are the interfaces are there. Send it to the SMS. So this is the one SMS or alert, right? So then comes the next case study I'm taking for the smart cities. We already have talked about the intelligent transport system. You can see the smart cities where the wireless sensor networks introduces the concept of our life, which is smart cities, right? And a smart city will permit us to know the several important value like the city pollution, noisy points, smart line management, and many other applications, right? So you can see here the sensors, then monitors, environmentals, right? So a smart city where the entire city is, monitored intelligently. Here, the entire intelligent critical infrastructure is there because they connected to the IoT, they connected to the internet, cloud, so cyber physical system is there, right? And so this is the very good example, smart city, very good case study if you can consider like a city of Pune, city of Bangalore, right? Right. So here you can consider the kind of you can take the one building, for example, one building you can monitor, right? So one town you can monitor, one part of the city you can monitor, say like city pollution, then noisy points, smart line management, smart garbage collection and garbage distribution. So many things that can be done in smart cities, right? So many things are there. Then underwater wireless sensor networks, though we have talked about the underwater sensor, wireless sensor networks like monitoring the sea water quality, monitoring the movement of the object inside the sea, underwater, right? So these network consist of several sensor nodes and vehicles deployed underwater. So a small, motor vehicle you can actually develop and deploy, and they will go and collect the data through the sea, through the ocean, through the submarine, right? Autonomous underwater vehicles are used for gathering the data from these sensor nodes. So nodes are there, right? But you can, how you will be collecting the data? Nodes you have deployed inside the underwater. I mean, underwater you have deployed this node, but you need to collect the data time to time. Next, the challenge is the energy, right? Underwater again, if some nodes are, damaged somehow, okay, then you have to replace it, okay. So many challenges are there in the underwater networks. A challenge of the underwater communication is a long propagation delay. See, delay will be more in the underwater if you compare to the surface wireless sensor networks, like in forest or right. Underwater propagation delay will obviously will be there because communication channel is different. Most of the communication like signals, they will go very slow, right? So bandwidth is the issue, propagation delay is the issue, sensor and sensors, sometimes the sensor node will fail. So these are the big challenges. So wireless underwater sensor network, there are three types of the communication in the underwater sensor networks wireless. Okay, so underground, to underground link, underground to overground link, and above ground to underground link. See, these are the three types of communication in the water underwater sensor networks, right? What are those? Let me repeat. Underground to underground link, underground to overground link, and above ground to underground link. Right now, let us go into the depth of these underwater sensor networks. Underground to underground link, in which the both sender and receiver are buried inside the underground and communicate through the soil. Okay, this is the underwater, underground to underground. Underground to overground link, in which the sender is buried and receiver is above the ground. Monitoring data is transferred to the above ground relays or synced through these links. Above ground to underground link, in which above ground sender node sends message to the underground receiver. So sender is on the above ground and receiver is underground. This link is used for the management information delivery to the underground sensors. So there are various potential application of the wireless underground sensor networks. Environmental monitoring, earthquake and landslide monitoring you can have, okay, sports field maintenance, precision agriculture. There are various kind of the wireless underwater, right? So now these all are the things that we have talked about the applications, right? Next is design issue of the wireless sensor network. Okay, so I hope everyone is listening me, right? Is it interesting, everyone? Rahul, can you hear me? Hello, Professor Jugal, are you there? Okay. Can anyone tell me whether I am audible or not from the participant side? Even you can type in the chat box. Or just I am alone speaking or you people are just logging. What is this? Huh? Sanjay, okay. Anyone else? Professor Sanjay is there. Okay. Right. So, okay, Professor Sanjay. So, I'm next topic related to the design issues of the wireless sensor networks that I'm talking, right? So, now you are much aware about the sensor networks. Huge challenges are there, and many challenges placed by the deployment of the sensor networks, which are the superset of those found in the wireless side of networks. So sensor nodes communicate over the wireless lossy channels with no infrastructure and limited, usually non-renewable energy supply of the sensor nodes. At the starting, I have told you that every sensor nodes are energy efficient, energy capable, right? And they are having the life of the energy, maybe for the 1 month, 2 months, 6 months, right? 4 hours, 3 hours, like you are charging your mobile and your mobile charge continue up to 4 hours, 5 hours, 10 hours. Similar way, node is having the energy life, right? So maximize the lifetime of the network. The big challenge is how you will be maximizing the lifetime. If you are preserving the life energy of the node, obviously your network will increase the lifetime. The protocol need to be designed, okay, in such a way that the beginning from the objective of efficient management of the energy resource, right? So here there are many challenges like fault tolerance is the one thing, scalability is the another things, production cost is the another third challenge is design issue, hardware constraint is the fourth part, sensor network topologies or structure is the fifth one, transmission media is the sixth one, power consumption is the seventh design issues. Okay, so there are many, but I have talked the seven, the design issue. The very first one is the fault tolerance, and you all are aware the fault tolerance. Sensor nodes can fail due to the hardware problems or physical damage or by exhausting their energy supply. Just you are bombarding the information to the sensor node, and sensor nodes, they consume the huge energy just to process the unwanted information. So the sensor node dry, exhaust their battery, exhaust their energy supply. Okay, then node failures to be much higher than the one normally considered in wired or infrastructure base. Right. So in infrastructure-less networks, the node failure is considered very high. If you are talking about the wired network, there is no chance of the node failure. But once the node failure is there, what happened about the data? Right. So the protocols deployed in the sensor networks should be able to detect these failures as soon as possible and be robust enough to handle the relatively large number of failures. So your nodes of the network should be so robust that if anything went wrong, right, right. So it automatically start from the place where it left out. So while maintaining the overall functionality of the network, right. So detect these failures as soon as possible and be robust enough. So the fault tolerance is there, right? So fault tolerance is the major challenge. If any node is down, you have to make it working condition, and whatever the damage has happened, you should have to retrieve it. So node failure to be much higher than the one normally considered in wired or infrastructure-based wireless network. That is the fault tolerance. Next is a scalability. Wireless sensor networks vary in the scale from several nodes to the potential several hundred thousand of nodes. So it all depends on the applications and your requirements. Your network node could be the 10, your network node could be the 1,000, your network node could be the 100,000. It all depends what kind of networks that you apply and how much data you want to generate, what kind of the data you want to generate, the feature of the data, right? And the protocols deployed in sensor networks need to be scalable to these levels and be able to maintain the adequate performance. So scalability is the second design challenges. The third is the production cost. And all the, please remember, all the network sensor network company, those who are designing the nodes, they are much concerned. They are doing the day and night research and development in this area. So production cost is the one part, because many deployment models consider the sensor nodes to be disposable device. Sensor networks can compete with traditional information gathering approaches only if the individual sensor nodes can be produced very cheaply. Right. So production cost is the another challenge. Okay. Okay. Fourth one is the hardware constraint. See, whenever you are talking about the IoT or critical infrastructure networks or intelligent critical infrastructure network or cyber physical system, everything is connected. Please remember, and many hardwares are they involved to process these to generate the data, right? So hardware constraint is one important design issue in the wireless sensor networks. And the minimum every sensor node to have the sensing unit, a processing unit and transmission unit and power side supply. Please remember, in node, okay, wireless sensor networks nodes, these are the mandatory four parts. Wireless sensor node must have the at least the four parts. Optionally whatever they have, but four parts are mandatory. The first one is sensing unit. Node should must have the sensing unit. Okay. Second is the processing unit. Node should must have the processing unit. Third is the transmission unit, because you want to transmit the data from one place to the another place, from a node, from the node which generated the data, that is the sender node, to the sync node which will process the data to the cloud, right? So everywhere you need to transmit and these data, and for the transmission you require some communication channels. So transmission unit is there, right? And the fourth one is mandatory, is the power supply. Node will not work unless and until you give some power or energy, right? So these are the hardware constraint which I have talked. Optionally, the nodes may have several built-in sensors or additional devices, such as the localization system to enable location-aware routing. Uh, Additional functionality comes with additional cost, increase the power consumption, like physical size of the node, and to be balanced against the cost and low power needs. So always there is a trade-off in between the costing of the nodes and the low power needs. If you want to have the maximum power, energy enabled nodes, you have to pay obviously the more, okay, amount. Okay, so fifth one is sensor network topology and structure. So if you are having, the movement in the wireless sensor networks, okay, so then in that case, you have generated the data from the nodes, but topology will change. Okay, topology will not fix. Okay, because it is the infrastructure-less networks, and if it is the mobile-based wireless sensor networks, where the mobility is there, right? So once the mobility is there in the sensor network, obviously the network topology will change, because the devices is moving from one place to the another place, and they are changing their signals, they are changing their networks. Okay, so sensor networks topology or structure design is the another challenge. And wireless sensor networks evolve in many aspects. They continue to be networked with constant resource in terms of the energy, computing power, memory, communications, capabilities, and of these constant energy consumption is of the paramount importance, which is demonstrated by the large number of algorithms, techniques, and protocols that have been developed to save the energy and thereby extend the lifetime of the network, right? Topology maintenance is one of the most important issues research to reduce the energy consumption in wireless sensor networks. So topology means the way that you have deployed the sensors and nodes, the way that you have created the networks. Okay, that is the topology. That is the layout. Okay, so topology maintenance is one of the most important issues. And see, your algorithm should be designed in such a way that it should, when the node is moving from one cluster to the another cluster, right, you have to make your algorithm so adaptable, right? So implemented using the radio communication, right, over the popular ISM band. What is the ISM band? Industry, scientific, and medical band. So transmission media, there are many transmission media there. Like we have talked about the radio signals, opticals, infrared communications, right? So sensor networks, they use the kind of these things, right, for transmission, like infrared communications, radio signals, opticals, and nowadays the robust and virtual interference free transmission media are there, right? So this is, and the whole media, they are having with the ISM bands. Power consumptions, challenges of the sensor networks revolve around the limited power resources. The size of the nodes limited, the size of the battery. So we already have talked about the power consumption, because the sensor nodes is having the limitations of the power, right? They are having the life. So software and hardware design needs to carefully consider the issue of the efficient energy use. For instance, data compression, reduce the amount of the energy data uses, right? Uses the additional energy of the computations, right? So we have talked about, we have talked about the basic concept of the wireless sensor network. We have talked about the data we generated in the critical infrastructure system. We have talked about the applications. We have talked about the design issue in the wireless sensor network critical infrastructure. Now, the next thing that I will be covering about the structure of the wireless sensor nodes. So all of you please be attentive here. Wireless sensor networks, now you are aware, as part of the critical infrastructure, right? You make it the entire network intelligent way, and so many applications we have covered, 15 applications and case study that we have gone through, right? Sensor node is made of the four basic components, please remember, and we already have talked it, right? So mandatory are the sensing unit, processing unit, transceiver unit, and power unit. Okay, also has the application dependent additional components. Application to applications, the other requirement will vary. Okay, so structure of the wireless sensor node having these are the four mandatory components. Then you are having the structure, okay, based on the applications, because many applications are there and their requirements are is different. Okay, so application dependent additional components such as the location finding system. Okay, if you want that special localization to find out the localization of the nodes or movement or object, then you have to pay something extra. So these whole things is work out by the company which they make the sensor nodes, right? So they are doing lots of research work in this area: location finding system, power generation, and mobilizer. Then you these are the additional things. Sensing units are usually composed of the two subunits, sensors and ADC. ADC means analog to digital converters. So see, this is the case study which I am taking here. Okay, how this case study is for the structure of the critical infrastructure system, that is the wireless sensor networks where the nodes are deployed. You can see, all of you please see here, you can see that this is the sensor field. Okay, this is what? This is the sensor field, this area. You can see that these all the nodes are deployed. Okay, and you are here as a user. Use data is generated. See, okay, data is generated from this field. Okay, these are the sensor nodes. This is the base station. Base station and sync node both are the same, so you should not get it confused. Okay, so sensor node, they have generated the data, send it to the base station. Base station, they had send it to the cloud. Okay, using some communication channels, they send this information to the cloud or internet, and thereafter this cloud is connected to the users. Okay, so user, they process this data, right? So processing is done here. Please remember, processing, data aggregation is done here at the base station. The data generation is happening here in the sensor field, maybe the agriculture field, maybe the smart city field, maybe the healthcare, maybe the military, right? Many applications that we have covered, maybe the environmental, maybe the industry oriented, right? So here is the sensor nodes. Okay, but what kind of information you want to collect it, you have to, you are the user, you have to instruct to the sensors. Okay, so you can see here the sensor node is there. So sensor node, this is the structure, positioning finding system and mobilizer. Okay, so positioning finding system and mobilizer. Positioning finding system, here the sensing unit is there. Sensing unit where the sensor is there and ADC is there. What is the responsibility of ADC? ADC means they will convert these analog to the digital. Okay, so the sensors, they sense this information. Positioning finding system, this after this sensing, they convert it to the digital, right, data, and thereafter they go to the processing unit. So you can see here the ADC, they convert it to the digital, then send it to the processing unit. So processing unit, the processor is there, right, and the storage capacity is there, because to process the data you need some storage area, right? So storage is there, processor is there. These are the two parts of the processing unit. And these are the two parts. Sensors and ADC are the part of the component of the sensing unit. And thereafter they transmit it to the transceiver. So transmission unit is here. So you can see the transceiver is there. So transceiver transmission unit is the part, and here it is the power unit. So power generation is there. So these are the four things that we have talked, that these are the four components are mandatory of any sensor nodes. These are the mandatory. Okay. Which one? Sensing unit, processing unit, transmission unit, and power unit. Right. Apart from these, additional components is differ from application to application, like location finding system, like power generation or mobilizer is there. Like if your node is moving, then certainly you need the mobilizer, right? So this is the structure which we have talked. We already have discussed all these things. Then communication structure. Now we have talked about the node structure. Now we will be talking about the communication structure. So you can see this is the communication structure of the wireless sensor networks. So communication structure, there are 5 layers. Okay, the sensor, wireless sensor network, they are having communication structure 5 layers. Physical layers, where all the transmission media, data link layer, where the MAC is there. For the routing, the network layer is there. For the transmission, UDP, TCP, right, transport. Here it is, the transport layer is there, and application layer. And apart from this, all these are used for the task management, mobility management, power management, right? So all these things are there, right? So here you can see, am I audible, everyone? Hello? Am I audible? Okay, good, Professor Sanjay. So thank you. So now we are covering, we have covered many things, right? So here you can see the communications structure. Now we are talking about the communication structure, where the sensor nodes are usually escorted in sensor field, and the scattered sensor nodes has the capability to collect the data and route the data back to the sink and these things, right? So data are routed back to the end users by the multi-hop infrastructure, lace architecture through the sink. And multi-hop we already have talked, right? So multi-hop like that, right? And they are having the transmission bandwidth also. The sink may communicate with the task manager node via the internet or satellite. Okay, so here you can see previously we have covered the sink node. This is the sink node. This is the base station. They communicate these data to the internet or cloud through some transmission media, right? Through some channels. So protocol stack used by the sink and the sensor nodes refer to the these things. So these are the protocol stack we already have talked, right? So protocol stack combines the power and routing awareness. So you can see power is there, mobility, routing, power efficiently through the wireless medium and promote the cooperative efforts. Different type of application software can be built and used on the application layer depending on the sensing task. This layer makes the hardware and software the lowest layer transport to the end user. So different type of applications of the wireless sensor networks are there. Transport layer help to maintain the flow of the data, right? And network layer, you are aware that network layer is used for the routing and data send it to the next layer, that is the transport layer. Specific multi-hop wireless routing, so simple like wired routing will not work here. Even for the wireless, other wireless networks routing will not work. Wireless sensor networks, they are having the different kind of the routing protocols, right? So the routing protocols, the basic duty is to find the correct path, send it to the sensor node, send it to the sync node, right? So these are the basic responsibilities and duties of the routing protocols here. So network layer play the very important role. Data link layer we already have actually discussed. Data link layer wherein you can actually see the multiplexing is done, data streaming is done, error correction is done, error control is done at the data link layer, frame detection is done, and media access control is done, right? So these are the things happening at the data link layer. And since the environment is noisy and sensor nodes can be mobile, the MAC protocol must be aware and to minimize the collision with the neighbor broadcast. So CSMA CD technology should be there, right? CSMA collision, this avoidance technique, right? And the physical layer, you are aware, we have discussed already, like physical layer, they includes the modulation, frequency selection, data encryption, transmission, receiving technique, channels, power supply, everything. This is the part of the physical layer in the wireless sensor network critical infrastructure system. And the power, mobility, task management, phones, monitors, the power movement and task distribution among the sensor nodes. These planes help the sensor nodes coordinate the sensing task and lower the overall energy consumption. So this is the overall yeah, parts of this. Data aggregation in wireless sensor networks. Okay, so you can see that next topic is the data aggregation. So let us have some data aggregation is very important topic in the sensor network critical infrastructure. So let me take some break, 5 minutes. Is it okay, everyone? Right? Professor Prakash, Meena, can you hear me? Hello? Yeah.
Yes,
Okay.
sir. Yes, sir. You are audible.
Right. So let us take break for 5 minutes. Okay.
Okay, sir.
Hello, good afternoon. Welcome back, everyone. Anyone, please reply me. Can you hear me? Can you see me? Professor Jugal, Dr. Jugal Dave, are you? Rahul, hello. Please write in the chat box whether you are able to listen me or not. Hello.
Yes, sir.
Yeah, Rahul. So, yeah. So, my screen is visible. Rahul, can you see the screen presentation?
Yes, sir. Yes.
What is the topic? Data aggregation, right? So I hope everybody is able to see the screen, right? So next topic is related to the data aggregation in wireless sensor networks. Okay. So data aggregation, huge data is collected, but you have to transfer the data only the useful information by removing the duplicate data, because in the networks the huge data is generated, and uh, the same data the collected from the multiple sources. Okay, so you have to aggregate these kind of the data. So data aggregation is the process of collecting and aggregating, combining the useful data information in the particular region of the interest. And data aggregation is considered one of the fundamental processing procedure for saving the energy. Data aggregation is an effective way to save the limited resources, right? So if you apply the data aggregation technique, this is the best way that you can save the battery. You can save the limited resource. That is what the battery, right? And data aggregation in wireless sensor networks, when critical infrastructure, when I'm talking, due to the high node density in the sensor network, same data is sensed by many nodes, right? So in the sensor field, you can see the same data is sensed by the multiple nodes, which results in the redundancy. And if you are transmitting the same data, right, redundant data to the sync node, to the destination node, then you are wasting your energy, because transmission also requires that energy, right? So energy power is required for the data transmission, for the data generation, for the computation, right? So energy consumption is less for the computation as compared to the data transmission. And effective data aggregation technique can enhance the energy efficiency and network lifetime. Okay. So effective data aggregation technique can enhance the energy efficiency and network lifetime of the wireless networks. And the main goal of the data aggregation algorithms is to gather and aggregate data in energy efficient manner so that the network lifetime is enhanced. Okay. So wireless sensor networks have limited computational power and limited memory and battery power, and this leads to increase the complexity for the application developers. And you are aware that the node is having the limited battery power, so this leads the increase to the complexity of the application developers or researchers, and always result in applications that are closely coupled with the network protocols. So data aggregation is the process of aggregating the sensor data using the aggregation approach. So there are multiple aggregation approach that you can see, and data aggregation taxonomy, like the parameters that you can consider. Energy efficiency is the one, network lifetime is the second, data accuracy, latency, data aggregation rate. So these are the 5 parameters of the data aggregation. So whenever you are monitoring the wireless sensor critical infrastructure, right, you can see that these are the parameters, like how your algorithm is so energy efficient, how your network is having the lifetime, how your data is transmitting accurate, how much latency is there, data aggregation rate, what is the data aggregation rate, so rate of the data aggregation is what, right? So these are the 5 parameters that you can consider. Now let us see the definition. What is the energy efficiency? So energy efficiency, it means the amount of the data successfully transmitted divide the total energy consumed to transfer those data. So if you apply these equations, then you can certainly, you will get it the energy efficiency, right? So thereafter the network lifetime. So network lifetime means the number of data aggregation rounds finished till first sensor node exhaust of its energy. So that is the network lifetime. I repeat, the number of data aggregation rounds finished till first sensor nodes exhaust of its energy. So that is the network lifetime. Third parameters is the data accuracy. Data accuracy is equal to amount of the data transferred successfully divided by the total number of data sent. That is the total data accuracy. So ratio of the amount of the data transferred successfully, that is the packet delivery ratio you can consider. So successfully, how much data you have transmitted to the destination, right? Then the total amount of the data generated. Then latency. What is the latency? Latency means the time of the receiving data and the minus the time of the sending data. So you can see the summation of n I is equal to 1, right, with reference. So this is the latency. It is the amount of the time between the data produced at the source node and the data packets received at the sink node. Then data aggregation rate. So this is the equation. Data aggregation rate is denoted by alpha of I, is defined by as the amount ratio of the amount of the data aggregated successfully to total amount of the data sends. So this formula use DAG divided by distance multiplied by 100. So where DAG is the amount of the data aggregated successfully at distance, means the total amount of the data sends. I mean, how much data is aggregated and how much the data is sent. So these are the things. And data aggregation models, this is the technique. So these are the parameters taxonomy that we have talked. This is the data aggregation technique. If you see, these are the 2 examples which I have taken here. Base station, and this is the base station. How many nodes are there? You can see that there are 7 nodes. 1, 2, 3, 4, 5, 6, and 7. So first layer you can see this 1, 2, 3, 4, 5, and second layer these 6, 7. You can see the data aggregation model and non-data aggregation model. Which one is the data aggregation model? Left side is the data aggregation model. Right side is the non-data aggregation model. Why? You can see in the sensor field here, there are 7 nodes are deployed, right? So you can see the 1, 2, 3, 4, 5, these nodes, they generated the data and they send it to the node number 6 or node number 7. But if you see, if the data is aggregated here and only the aggregated data is transmitted to the base station, then it is the data aggregation model is there. But if you have generated the data, right, and the same data you send base station without aggregation, then on a non-aggregation model. This that aggregation technique. Now we are talking about the technique, the methods, the algorithms, right? So direct transmission, if you all the nodes they are transmitting to the sensor nodes, this one, right, then use problems are there. So algorithms, these algorithms should be so optimized. So this is known as the direct transmission. When all the sensor nodes they are transmitting their data directly to the base station, right? And this is the Pegasus. Pegasus full form. The second algorithm is the Pegasus, power efficient gathering for sensor information. Here you can see they make here is the base station. These are the the sensor fields, and they process the data. So you can see they all these nodes they generate and they process both. You can see these they have generated the data and they process it and they send it to the next node. So these process continue and they prepare what? They prepare the channel of this. So this is the power efficient gathering for sensor information. This is right. So these is the another algorithms. So how data aggregation is done in wireless sensor networks? So wireless sensor networks, you can see the data aggregation, like sensor data, sense the data collected from the sensor nodes, apply the data aggregation technique like leech, tag, directed diffusion. Aggregated data is here. Then sensor base station PC interface is there here, right? So all these data, from generate sensor node generated, apply this technique, aggregated data, and then it goes to the base station, right? So this is the part of the data aggregation technique. So there one popular algorithm, all of you please see, very interesting algorithm is the leech protocol. Which protocol? Leech protocol. And leech full form is the low energy adaptive clustering hierarchy, leech protocol. So data aggregation, once the data is generated, data should be aggregated. And leech is the very popular protocols, right? So data aggregation is the process of aggregating the sense data using the aggregation approach. Then the algorithm uses the sensor data from the sensor node and then aggregates the data by using some aggregation algorithms, such as centralized approach. So leech, low energy adaptive clustering approach, tag, tiny aggregation approach. And this aggregated data is then transferred to the sync node by selecting the efficient path. Okay. So cluster based approach is there. Leech is also the cluster base. You see, it name itself suggests the cluster. So low energy adaptive cluster algorithms. So most cluster algorithms is the most efficient algorithms, right? So leech is the cluster base. Here you can see this is the one cluster, this is the second cluster, this is the fourth cluster, this is the third cluster, right? So four cluster are there. These are the nodes. This is the cluster heads. This is the sync node. So all these fields, all these nodes, they generate the data, send it to the these nodes, and they send to these cluster heads, right? So cluster. This is the cluster based algorithm. So leech is the low energy adaptive clustering algorithms which we have talked. This is the cluster head. You can see these. One cluster head, this one cluster head, this one cluster head. So each cluster heads, they connect to this, and this is not a sync. Okay. So cluster head and then the member node. Okay. So you can see the cluster head maintains the TDMA schedule with its member node. Time slots are assigned to each cluster member for communication with cluster head. Cluster members can sleep except in their own time slot. Cluster heads, right? So cluster head send the data to the sync or other node. So these all are the cluster head responsibility. Now this leech network has two phases. So one is the setup phase and second is the steady phase, right? So setup phase where the cluster heads are chosen, and steady phase where the cluster heads is maintained when the data is transmitted between the nodes, right? So these technique and leech protocol, they follow these algorithms. They are having these equations. You can say cluster heads can be chosen stochastically, probability based on this algorithm. So you can see the graph. Okay, so graph belongs to all the nodes. Okay, so T of n is equal to P upon 1 minus P multiplied by R modulus P raised to minus 1. Okay, so where n is the random number between 0 and 1. Okay, so and P is the cluster head probability. Here P is the cluster head probability, and G is the set of the nodes, right? So cluster heads the previous nodes. So if n less than is equal to T of n, then the node becomes the cluster. In that case, if these equation fulfills, then and then only node will become the cluster, like out of these. So you can see like 1, 2, 3, 4, 5, 6, 7. So out of 6, one node will become the cluster based on this equation, right? And this is the algorithm of the leech protocol. Okay, and the algorithm is so designed, so beautifully designed, that each node becomes the cluster head at least the once. So every node, like 7 nodes are here, every node will get the chance to become the cluster at least the one time, right? So this is then. Okay, so leech is stochastic algorithms and leech C algorithms is there, right? Proven to increase the first node lifetime. So if you apply the leech protocol, you can see that the lifetime of the network is increased. Okay, and most of the researchers PhD thesis they have done, okay, over the data aggregation technique. And most of the researchers they have considered the leech protocol as a base protocol, and they have made some changes in the leech protocol for the data aggregation, and they have given their own name for the protocol. So like extended form of the leech, many researchers they have extended the work of the basic leech, right? And they have given their own name, that is the leech B, leech E, leech H, tail leech, leech me, leech C, leech F, leech M, multi-hop leech. Huge research scope is there in the in the data aggregation technique. So you can see the variation of the leech. Many work has been done in the leech using the leech. Then third algorithm is the tiny aggregation. And the generic aggregation service, two essential attributes of this service, provide the simple declarative interface for the aggregation, inspired by the aggregation operators in database query language. Intelligently distribute and execute aggregation operators in the sensor network in a time and power efficient manner, and is sensitive to the resource constraint and lossy communication properties of the wireless sensor node. Right. So you can see this is the fourth kind of the data aggregation. Third is we already have seen centralized approach. So each sensory node select the most powerful node among its neighbors and send the data packet via the shortest possible. So assign the aggregation work to one node based on the selection or the a point or node which is having the more power and computational capacity. So all the node will transfer the sense data to the central node. In this scenario, all the nodes are aware which node is working as central node, and central node aggregate these data and send to the sync node. Right. So you can see these data aggregation techniques. So centralized approach is there. Then network based approach is there. Network based without with size reduction and without size reduction. This is the comparison of the data aggregation technique. You can see the centralized approach, network approach, tree and cluster approach. You can see that the cluster based approach is much efficient. Delay is very less, redundancy is very less, accuracy is very high, traffic is very less, energy consumption is very less. So you can see that the cluster based approach for the data aggregation technique is the good one. If you compare with the centralized network or tree based algorithm for the data aggregation technique, cluster based is the good one. These we already have talked. Thereafter, the many security issues are there, like data confidentiality. Is there the same data should be sent to the expected destination, right? So data confidentiality, if you are targeted to send the data to the node X, data should reach to only the node X. It should not go to the anyone else, right? Data integrity should be maintained. No one can change the data. Yeah. So these are the security requirements. Freshness, data should not be the stale, right? So need to ensure the freshness of each of the message, right? Otherwise old data, maybe you can have some the kind of the suspicious data. So nonce or time specific counter may be added to each packet to check the freshness of the packet. Availability, your network should be available, and so over the reactive and time of the response of the system to transmit the information. So network should be available 24/7. You should have to avoid any kind of denial of services. Authentication must be there. Access control, non-repetition is there. Forward and backward secrecy is there. Self-organization security is there. Secure localization. So localization play a very important role. So you localization of the device, localization of the nodes, you should also secure it. Time synchronization is required, right? So based on these all, there are many security issues which we have talked. Thereafter, based on the capability of the attacker. Okay, so outsider versus insider attack can be there in the critical infrastructure. Passive versus active attacks, mode classes, laptop classes attacks. So there are many attacks are there. You can see Based on the protocol, physical layer, device tampering, jamming, eavesdropping, attack happening in the physical layer. So solution is what? Provide the proper encryption, provide the access restrictions, right? Then data link layer security like collision, unfairness, exhaustion, this should be avoided. So identity protection and misbehavior detection should be there. Network layer attacks like false routing, spoof, black hole, sinkhole, Sibyl, selective. So you have to provide some solution over these in critical infrastructure system, like over the network layer, like routing access restrictions, false routing, information detection. So this is the one example, like if we have considered the sinkhole attack at the network layer. So many kind of the attacks happens, and many of the attacks happens in the network layer only, right? Application layer, selective message forwarding, data aggregation detection, attacks kind of the things at the happens at the network application layer. So the solution is data integrity protection. You have to implement it. Data confidentiality protection. You have to implement. There are many tools available, like critical. When we are talking about the critical infrastructure, there is a huge investment to establish the critical infrastructure. So for the researchers, there are many tools available where you can create the kind of the critical infrastructure requirement scenario, and you can do the lots of research work. So many tools are available like NS2, NS3, Tossing, MStar, Omnet, JSIM, Atumi, Avera, Sense, Kuja, Castilia, SON, Visual Sense, Prowler, NetSIM, UWSIM. So if anyone is working in the underwater sensor network, you can refer the UWSIM. I work extensively in NS2 and NS2. GSense emulator is also there, right? Security, huge challenges are there that we have covered. Okay, so final remarks, we can see here that can you think of any application where the wireless sensor network would be best solution to provide in the critical infrastructure system? Do you foresee wireless sensor network becoming ubiquitous within the next 10 years or during your lifetime? So these are the questions and final remarks for you. These are the papers which I have referred to prepare this presentation. So 2025 papers we have referred. You can see 25 papers you have referred. Wireless sensor network, Dr. Sudip Mishra, Arshad Jumka, Sandeep K. Kulkarni on the design of mobility, right? Kishore Kotlani, Christian, these paper. So these all are the papers that I have referred. Okay, so if anyone is having any query, you can ask me.